Welcome to Chapter 4.3, Naming and Writing Ionic Formulas for Metals with a Single Charge. So we're going to have one video for the first part of this section and then another video for the second part. So we're going to learn how to name ionic compounds with metals that form only a single ion. Okay, these include the metals that we've discussed so far, your group 1, your group 2, and your group 3A metals. So I probably should have even put A there. Okay, these are your representative metals. Okay, the guide for naming these ionic compounds is to first identify the cation and the anion. You can do this by looking at your periodic table. Then you're going to name the cation by its element name. And you're going to name the anion by using the first syllable of its element followed by IDE. So an example of this would be fluoride instead of fluorine. Okay, you keep the first syllable and then add IDE at the end. And then you're going to write the name of the cation first and the name of the anion second. Okay, so we know that, just to review, our cation is going to be the metal and the anion is the nonmetal. Because metals form positive ionic charges and nonmetals form negative ionic charges. Okay, so we're just going to use these steps. The best way to do these is just to practice. So we want to name the ionic compound K2O. Okay. First you want to identify the cation and anion. So we know that K is in group 1. And the anion is in group 2. So just a reminder, how we came up with this formula is that our charges have to balance in order for us to know what our subscripts are going to be for our formula. So if we write the formula here, we need 2 plus only 1 oxygen to equal 0. And that gives us K2O. We'll do some more practice at the end of the video as well. Okay. Now we name the cation by its element name. So the cation is potassium. That's its element name on the periodic table. The anion is oxygen, but we only keep the first syllable and then we end the element name with IDE. So oxygen becomes the NiO2 minus becomes oxide. Okay. So we write the name of the cation first, which is our metal, and the name of the anion second, and so the proper name would be potassium oxide. Okay, so let's name the following compounds for practice. Okay, so if we have calcium, we're looking at A, and we have oxygen. Okay, we're going to find calcium on the periodic table, or Ca, if you didn't know it was calcium. And it's in group 2. Okay, so it has a 2+ charge. Oxygen is in group 6, so it has a 2- charge because it needs to gain 2 electrons to be like the nearest noble gas. Okay, and so these charges already cancel here. Okay, they already become 0. Plus 2 minus 2 equals 0. Therefore, we just need 1 of each atom. So that's how we came up with the formula that was given to you. Okay, and now we're just going to write out the names. So we would say calcium, and then we know we have oxygen, so we end in IDE, so it's calcium oxide. Okay, and just reviewing as we go, we're just naming, so really the charges here aren't too important, but they are for writing formulas, so we're going to be doing that here in a minute as well. Okay, we have aluminum, okay, so we have Al, excuse me, you go and find, okay, the first thing also, I forgot to mention this, is you want to be sure you recognize that these are ionic compounds because they contain a metal and a nonmetal. Okay, aluminum is a metal, group 3 metal. and oxygen is a nonmetal. Okay, so when we combine these to get a total charge of 0, I'm just going to show you how we come up with the formula. Okay, we're going to have 2 aluminums for every 3 oxygens. So 6 minus 6 equals 0. Okay, so remember, this is your subscript, or your number of ions here. So that's where we got Al2O3. Okay, so now we want to name these. We know we have a metal, so it comes first. We have aluminum. We have oxygen again, which we know we drop the ending and add IDE. So we get aluminum oxide. Okay, we've already looked at magnesium chloride quite a few times to see how we get the formula here. Okay, so we're not going to go through how to come up with the formula. Okay, so we're just going to find Mg. We know that it's magnesium. And chlorine becomes chloride. Okay, so if you weren't really looking at how to come up with the formula, which we did here, okay, if you were just looking at naming, you name the metal first, calcium, just by what its element name is on the periodic table, and then you end with IDE on the non-metal. Okay, but this portion that we did here, showing how to come up with the formula, is important for later. Okay, it's important now. So we want to write the formulas and the names for the compounds of the following ions. Okay, so if we combine sodium and we combine bromine, and we combine sodium or sulfur, or sodium ion with the nitrogen ion. Okay, so you can pause if you want to practice these, and then I'm going to go ahead and get started. Okay, so we want to write the formula and the name. Okay, so writing the formula really comes back to section 4.2. Okay, so we have a +1 on our sodium. So we have 1. Okay, our charge is already balanced here. Okay, and so we're only going to need 1 + 1 - 1 equals 0. We're only going to need 1 atom of each. So our subscript is an understood 1 for both of our metal and non-metal. Okay, now if we want to write the name, Na corresponds to sodium, and Br is bromine, but we end in IDE. Okay, we'll move across to if we have sodium, and we have ion, and we have a sulfur ion. So we have Na+1. Okay, this time our charge doesn't cancel. We have +1 and we have a -2. So our charge does not equal 0. And we know it has to. Okay, and so what we're going to do, so we're not sure how many atoms of each we need here, but we know that our charge is +1 on the sodium and it's -2 on the sulfur. So the only way, it looks to me, the simplest way would be if we have 1 sulfur and we have 2 sodium. 2 - 2 equals 0. So our formula looks like so. And we would say sodium sulfide. We have sodium. And remember, we're getting the metal ionic charge from the group number. Sodium's in group 1. Nitrogen is in group 5. So it needs to gain 3 electrons. So that's where that 3 comes from, to be like the nearest noble gas. So if we write out this, we would need 3 sodiums for every 1 nitrogen. Okay, 3 minus 3 equals 0. And we would say sodium nitride. Okay, if we come down to aluminum, in group 3, it has a 3+ charge. And bromide, a -1 charge. Okay, so if we know that we've got a -1, we have a +3. Okay, looks like the best way to cancel this would be to have 3 bromines and 1 aluminum. We have 3, and we would just name it simply as aluminum bromide. Okay, aluminum and our sulfide ion. Okay, so we have a 2- charge and a 3+. The only way to get these to cancel, it doesn't look like we can just use just one number here. So we've got a 3 and a 2. So kind of our common multiple here is 6. So if we put a 2 here and a 3 here, we get 0. So we need 2 aluminum atoms and we need 3 sulfur atoms. We would say aluminum sulfide. Okay. Aluminum has a 3+ charge, nitrogen a 3- charge, ionic charge, so they already cancel. Okay, so we get a +3 minus 3 equals 0. So we know we're only going to need 1 of each. Okay. And we would call this aluminum nitride. And the last thing I want to say here, it looks like I've have lowercase letters for the names of the metals, and your book actually has these uppercase, so you would want to have, so these A's here would be uppercase, start with a capital A, capital A, and then the sodiums would also be capital. So the first letter of the name would be capital.